Assalamu alaikum students. Our topic is quality engineering terminology. Means the terminologies which are used in quality control engineering. It has three subtopics: quality characteristics, quality engineering, and recent approach. In quality control engineering, the quality of product is assessed on the basis of the characteristics of that product, and those characteristics can be divided into three different categories, which can be physical, sensory, or time oriented. Physical characteristics are those which can be physically measured. Sensory are the ones which are sensed, which are related with our senses, while the time oriented are the ones which are assessed through the aging or the time or during the use of that product. So the example of physical characteristics are the length, mass, and viscosity. There can be more, but these are three examples of the characteristics of a product which falls in the category of physical characteristics. Okay, length is measured, right, in meters, feet, or inches, or micrometers, or millimeters, depending on the type of the product. So length can be height, width, breadth, anything, and then mass and viscosity. So these are the three types of characteristics which fall in the category of physical characteristics. And sensory can be taste. The characteristics which are related with taste means the sweetness of the product. Of course, these will be some food products, candies, drinks, things like that. So taste, sound, and appearance. So these are the three ones which fall in the category of sensory characteristics of a product. And time oriented, as you can already guess, that we also studied in the previous class, serviceability, reliability or durability, and repairability, because all of these three are related with the product during its usage. So if it is broken, so how easy it is to repair, or how often we have to repair it. If we need to repair it very less often, means only once in a few years, then that is durable product. And if it is broken or it is damaged or something happens to it, how easy it is to repair, that is called as its repairability. And if it is then the serviceability, that how easy it is to get the service for the product when there is a fault or an error occurs. So these are the three types of quality characteristics which are used for the assessment of quality of the product. Means we can assess the physical characteristics, or its sensory characteristics, or its time oriented characteristics. Then in quality engineering, there are two aspects. One is the quality assessment of a product, means how the quality of a product is assessed and what are the methods to assess the quality of a product. So the quality assessment is done on the basis of the characteristics, right? So specifications are the values or the measurements of the quality characteristics. For example, specification can be a length, it can be sound, it can be durability, means the any type of the characteristic is the means. For example, you can say that a ball bearing must be of this size, okay, or the dimensions, or we talk about the mass, or we talk about the viscosity of a product. So the specifications are the measurements of the quality characteristics. So the specifications Specifications are the measurements of quality characteristics. For example, it can be length, it can be sound, it can be taste, it can be serviceability or anything. So the specification is the measurement of quality characteristics, and this measurement, the data of this measurement can be of two different types. It can be either attribute or it can be a variable. The attributes are is the type of data that is discrete in nature, and variable is a type of data which is continuous in nature. So for example, in attribute we can say the number of customers which are entertained during one day, because the number of customers can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They cannot be 1.1 or 1.2 or 1.3, right? While the variable is a continuous type of data. For example, length of something, or mass of something. Length can be, and it can be 1.001 centimeters, or mass it can be acquire any value. For example, it can be 1, it can be 2, or it can be anywhere between 1 and 2. So this type of continuous data falls under the category of variable, right? And the values of these specifications, because this is the data, the specification will have a certain value, means the length will have a certain value, and these values have some specific terms that are used in the quality control characteristic. The value that is desired or for some specification is called as the nominal or target value. If we are designing something, if we need a product, we need a certain value of the specification, right? For example, this product should be 1 foot long, or it should be 5 millimeters thick, right? Or the nominal value in the serviceability or in the durability is that it should remain error free, or without any damage, or without any need for repairing for like 1 year or so. So these are the target values, or we call them nominal values. Okay, and besides nominal value, there is a certain acceptable range, that plus or minus, that the value can range in between those limits. So the nominal value is the one that we target, but this is the acceptable range. It can go the upper specification limit, and it can go to lower specification limit, and in between all this range, all the values for that specification will be acceptable, right? And in the assessment methods, there are two types of assessment methods which are used to assess the quality of the product. There are non-statistical methods and statistical methods. So in our course, we will study some of the statistical methods, but the non-statistical method which is used is the one it is actually any method which does not include any statistically devised procedures or experimental design, right? So if a product is designed and tested without employing any statistical design procedures, or including any of those structured procedures which can help in the design procedure and manufacturing processes, including in the manufacturing processes, those are non-statistical assessment methods, and one of those, and such a method is called as over the wall approach. In over the wall approach, a design engineer designs a product, then its prototype is prepared, and the testing is done in an unstructured manner, means that without the use of any specific statistical design procedures. So they are not included, so it is done in unstructured manner, and also without having the knowledge of the manufacturing processes of the components and the product as well. So in such an approach, there is a large margin of error, and it results in non-conforming products. So what are non-conforming products? These are the products which do not follow or which do not fit the specification requirements. So these are not necessarily defective products, these are still usable, but their performance will not be up to the mark. So such the non-conforming products may or may not be defective products. So the defective products are the ones which significantly deviates from their targeted or the promised performance, okay, or they are broken or damaged. So if they are not, means if they are still operate but their performance is not widely deviated from what was promised, those are called as non-conforming products. But if they deviate so much significantly, their performance is really poor and they are not safe for use, they are called as defective products, okay. And in the recent approaches, there is the use of concurrent engineering and CAD and CAM for automated design and manufacturing. CAD, you are familiar with it. CAD is computer aided design softwares like AutoCAD. So and CAM are computer aided manufacturing. So these two softwares are used for automatic design and design and manufacturing processes. And in concurrent engineering, this approach is used to this is the collaborative approach of engineers from multiple disciplines like quality control engineers and manufacturing engineers, also with the help of design engineers wherever necessary, to work together and make products which are better designed and manufactured and have good quality. So that's all for this topic, quality engineering terminology. If you have any questions, we can discuss during our next live session or on Gaizala. Thank you very much.